So let's start with a basic little overview of exponents. Again, it seems like from what you guys said, you already know this from 7th grade. But this, how can I read this? If I'm looking at this little numbers here, how would you say that out loud? Okay, 2 times 2 times 2. What's another way you could say this? 2 to the power of 3, yeah? Is that what you're going to say? What else? There's another way. 2, yeah? 2 with the exponent of 3, okay, and 2 to the third. 2 to the third. So all of those are correct. Those are all ways to say this. 2 to the power of 3, 2 to the third, 2 with an exponent of 3, or like Matthew said, 2 times 2 times 2. What do we call this big number on the bottom? Does anyone remember? It starts with a B. What is it? Visible? What did you say? Divisible? It starts with a B. Base. Hey, look at that. There we go. The base. Exactly right. The base is the big number on the bottom. What's my base here in this box? 2. 2 is my base. What do we call the little number up on the top? Exponent. Beautiful. What's my exponent in this box? 3. So think big number, base. Big base. Big number, base. So I got a base of 2 raised to the power of 3. And what this represents is not 2 times 3, right? A lot of people make that mistake. You just multiply it. But when we expand it out, again, just like Matthew said, this represents the base multiplied by itself 3 times. Or however many times our exponent tells us to do it. What is 2 times 2 times 2? Is that 6?
8.
8. 2 times 2 is 4. 4 is 2 times 2. Thumbs up if you're with me so far, and that's making sense. Okay, the fellas in the front, the fellas in the side, the back, ladies, okay. Good. Now, like bases, so our next little blank, like bases are 2 quantities that have the same base. So that big number is the same, but their little number, the exponents, might be different. Like we have in this second box. 3 to the power of 2 and 3 to the power of 4. What are my bases here on these two numbers? 3. Let's write off to the side, base of 3. With 2 different exponents. But that's fine. As long as our bases are the same, that's what we want to see. Now, we're going to do this kind of backwards of the way that I wrote it on here. Let's fill in this one blank. The product rule is going to help us multiply like bases. So if I had 3 to the second times 3 to the fourth, we're going to learn a shortcut, the easy way to do it, but the hard way or the longer way for us to do it is by expanding everything out. So what is 3 squared, or 3 to the power of 2? What would that look like if I expanded it out? Well, 2 to the third was 2 times 2 times 2. So this is going to be 3 times itself 2 times. 3 times 3. With me? You still using that glue? No. Put a cap on it so it doesn't dry out. How can I expand 3 to the power of 4? What would that look like if I expanded it all out? 3 times 3 times 3 times 3. So take a look. We're multiplying these like bases. Everybody looking up here? We're multiplying the like bases. If I expand this one out, I've got 2 of them. If I expand this one out, I've got 4 of them. How many 3s do we have in total? 3 times 3 times 3 times 3 times 3 times 3 is 6 of them. So what would my exponent be if we condensed all those back together? 6. Because 3 to the 6th is 3 times itself 6 times. That's the long way, like I said. Is that confusing at all? No? Okay. It might be. That's okay. The easy way is by using the product rule. Okay, that's the basis of this lesson. When you multiply like bases, just keep the base the same. Right? We started with bases of 3. We ended with a base of 3. But what we're going to do is we're going to add the exponents together. So 3 to the 2nd power times 3 to the 4th power becomes, keep the base the same. I'm going to take my 2 exponents and I'm going to add them together. You guys see that? What is 2 plus 4? 6. Is that the same exponent we found by breaking it all out?
Yes.
Exactly. So my answer is 3 to the 6th power. Like we see up on the board. If we expand all this out, we've got 6 total 3s, which we could condense all together as 3 to the power of 6. So in order to avoid writing out all these 3s, imagine if it was like 3 to the 20th power. Right? Imagine if it was 3 to the 20th power times 3 to the, 27th power. I'm not going to write out 3 times 3 times 3 times 3 20 times and then 27 more times. But how many total 3s do we have here? Well, if I take my first exponent and I add it to my second exponent, what's my total now?
47.
47. Look at how easy that was. We didn't have to write anything out. We just added the exponents together. Okay? So if we expand it out, you could count the total number of 3s and set that as your new exponent. But adding them together using the product rule is our shortcut, and a lot easier of a shortcut at that. While you're finishing that up, here comes the second note sheet.
You always have.
Did I leave you too?
Yeah.
Okay. Yeah, magic. So, let's take a look at these examples. Example 1, I got 5 to the power of 6 times 5 to the power of 2. Do I have like bases here? What is my base for each of these numbers? Anybody there? What's my base for these numbers in example 1? 5. 5 is my base. Both of these have the same base. So I can use the product rule. The product rule says if I'm multiplying, what does this little dot in the middle mean? Times, multiplying, exactly. So if I'm multiplying these like bases, all I have to do is keep the base the same and add the exponents together, giving me a new exponent of what?
8.
8. How'd you get 8?
6 plus 2.
Exactly. You just added the exponents together. 6 plus 2 giving you 8. Now example 2 looks a little bit scarier. I've got 3 terms. What is my base in example 2? My base is x. X to the power of 3 times x to the power of 5 times x to the power of 10. Are we multiplying all these bases together? No? What does this little dot mean? It means multiply. So yeah, we are multiplying them together. Now it doesn't matter if we have 2 like bases, 3 like bases, we can even have 10 like bases. They're all going to come together and condense into one single base of x. But the product rule says that we can take each of these exponents and add them together. 3 plus 5 plus 10. Which gives me, great job, 18. X to the power of 18. Now example 3. I got 2 to the power of 8. So my base is 2. Times 2 to the power of what? I don't see a power there. What exponent does this little old 2 have on it that we just can't see? A 1. When a base doesn't have an exponent, the actual exponent it has is 1. Why does it matter that we include that 1? We need an exponent to add to the 8 if we want to use the product rule. We're multiplying here. I'm going to keep my base the same. And I'm going to add 8 plus 1. If I don't include that 1 in there, I'm not going to add it to that 8. What's my new exponent for 2 going to be? 9. Are you writing any of this down? No? So don't forget about that invisible 1 on top of your base. If you've just got a regular old number, regular old variable, make sure to include that 1. Now sometimes we're going to have negative exponents too, like example 4. What's my base in example 4? 3. What am I doing to these like bases? You're multiplying them. So I'm going to use the product rule. I'll keep my base the same, and I'll add my exponents together. Now I've got this weird little thing. I've got 4 plus negative 2. What happens when we see a plus next to a minus like that? What does it make?
Negative.
A negative. Good. You guys are on top of it. It makes one big minus sign. And what is 4 minus 2? 2. So my answer is 3 to the power of 2, or 3 squared. Now, number 5, let's put a couple of these ideas together. What's my base in number 5? 4. What am I doing to all my like bases? Multiplying them. So what am I going to do with all my exponents? Am I going to multiply my exponents together? We're going to add them. Okay. I'll keep my base the same. I've got a 3 plus a negative 3 plus what? Plus 1. That lonely 4 has got a 1 on the top that we have to include in our product rule. Once again, what happens when we have a plus directly next to a minus? What does that make?
Negative.
A negative, okay. So now I got 4 to the power of 3 minus 3 plus 1. What is 3 minus 3?
0.
Plus 1?
1.
1. So we get 4 to the power of 1. What is 4 to the power of 1 equal to? 4. So in the same way that our question left that 1 off, right, we're going to leave the 1 off of our answer as well. We don't need to have that 1 there. If you really, really feel more comfortable doing that, that's fine. But I would ask that you simplify it, make it nice and neat, like that. Now, example 6. We got a lot going on here. How many total bases do we have here in example 6? How many bases?
4.
We got 4 of them. What is my base? Y. What am I going to add together? Okay, 0 plus what? 1. Good. Great job not forgetting that. Plus 2. Plus what? Plus negative 6. Again, we've got that plus minus. It's going to turn into just a minus. Now we're going to work out that whole expression right there. What's 0 plus 1?
1.
Plus 2?
3.
Minus 6?
Negative.
Negative 3. So we get a base of y with an exponent of negative 3. Okay, so last sheet for now. Want some more after the break? Everybody get that last sheet? Okay. So what did we get as an answer for example 6 again on the previous page? What did we get as an answer? Y to the power of negative 3. So we ended up with a negative exponent. A negative exponent. We do not want to keep our exponents as negatives. We do not want to keep our exponents as negative. We want to make them positive. And here's how we do that. It's 3 easy steps. Please make sure you're paying attention, because if you are, it's super, super easy. If you're kind of half in, half out, not paying attention, it is not going to make any sense. I promise you. For some reason, this gives people a lot of trouble in 8th grade. It's really not that bad. The first thing you need to do is put the base in a fraction over 1. So, like you said, we've got y to the power of negative 3. The first thing we're going to do, what's my base here again? Y. We're going to put that y over 1. Not too bad, right? Just put it over 1. Then we're going to flip the fraction. Also called taking the, does anyone remember this word when you flip the fraction? It starts with an R. We talked about it in the fraction workbook at the beginning of the summer. No one remembers? Reciprocal. That's right. On it today. Reciprocal. So we're just going to flip. The bottom is going to go to the top. The top is going to go down to the bottom. So what's now my numerator of this fraction going to be when I flip it around? 1 over. It's not just y, right? It's y to the negative 3. Okay, we flipped it. Once we flip that fraction, you're just going to make the exponent positive. So we get rid of that little negative sign. Boom. And that's our answer right there. Very, 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 very simple 3 steps. Put it over 1, flip it around, make it positive. Put it over 1, flip the fraction, make it positive. So step 1, just to get all those steps written down nice and neatly. Step 1 is put that fraction over what? 1. Put the y over 1. Then we're going to flip the fraction around so that the 1 is on top. Now that we flip the fraction, what do I do with my exponent? I'm going to make it what? Step 3, what does step 3 say? Make it what? Positive. So our final answer is the fraction 1 over y to the 3rd. Any questions about that process? No? Let's take a look at some examples. Example 7. I've got 2 to the negative 6th. What's my first step going to be? Put the base, which is 2, we're going to put it over 1. What's step 2? Flip the fraction. 1 over 2 to the negative 6th. Now that we flip the fraction, what's step 3? Make it positive. 1 over 2 to the 6th. That's our answer. So if you go step by step by step, it's very, very simple. Nick, you got this written down? No? Let's take a look at example 8. I got x to the power of negative 3. What's my first step going to be? Put the base in a fraction over 1. Now that it's a fraction, what am I going to do with that fraction? You're going to flip it. Now that you flipped it, what do you do with the exponent? Make it positive. And you should notice, hopefully, that all of my answers now are looking very similar. 1 over y to the 3rd, 1 over 2 to the 6th, 1 over x to the 3rd. It's 1 over whatever we started with, but positive. That's all it is. How about number 9? Example number 9. What do I want to do first in example number 9? Put a 1 on the bottom. Thank you, Nathan. Flip the fraction. Perfect. And then make the exponent positive. What is 10 squared? 100. So we could also say this is equal to 1 over 100. I really don't care which one you put. Now if you have 2 to the 6th, a little bit trickier to do, right? It would be 64. So if it's a big exponent, you don't really have to work it out. If it's like the power of 2, even the power of 3, you can if you want. Like example 4, we could have said is equal to 9. But 2 to the 9th, 5 to the 8th, don't work that out because it's going to be way too big. Last but not least, example number 10. What am I going to do in number 10? Put a 1 on the bottom, then what? Flip it around, then what? Perfect. What is 4 to the first power? 4. Just like that. Look at that. So anytime we are doing, we're going to learn a couple of these rules this week. We're just starting with the product rule right now. We're going to learn the second rule after the break. But anytime you are doing any of these rules, if your answer has a negative exponent, you then have to take these 3 steps to switch it up. Okay? If you get a positive, perfect. Leave it alone. Don't touch it. Just leave it as that. But if you get a negative, you then have to refer back to these 3 steps. Take the reciprocal, make it positive. Now that is your final answer. All right? Any questions I can answer about making negative exponents positive? Seems fairly easy, right? Okay.